Math 230, Cuesta College. I'm Joe Vasta, and we're covering section 2.2, set theory, and really what this is notation. Before we get started, show you the puzzle here. What letter comes next in this sequence? And so we have a sequence of letters, and you're trying to figure out which letter comes next. Okay. So with set theory, we've already talked about this in an earlier lecture. Our sets are usually named after capital letters, and so this set right here has 3 numbers in it. 1, 2, 3. We use these things called braces, and it's just a list here. So we're listing out the objects. A set is a collection of objects. So we could also write our set like this: 2, 3, 1. That's just as correct as this. So the set is a collection of objects, and it's unlike a sequence, which is a list. And this is not a list, this is just a collection. We could also, so this is good and this is good. This also describes the set 1, 1, 2, 3, 3, 3. Okay, but this is not simplified, because we have a repeat of 1. So I'll put that right here. This is not simplified. It still describes this set, just kind of like 2/4 is not simplified, and you should write 1/2. So you shouldn't have repeats. It's like saying I like the colors orange, orange, red, blue, blue, blue. It's kind of redundant, so we wouldn't want to write our sets with repeat elements, and that's something important when we're doing some notation with set theory. So let's go ahead, see what we'll be doing in the homework. In the homework, they'll be asking us these questions. They'll say find the following, so I better put problem number 1 up. Problem number 1 is this right here, which is B. And then there's an upside down U, and then C. So we're given a universal set, which is 1 through 6, and then all these guys are subsets of the universal set. They're part of it. So A, B, and C. And now they're asking us to find B, an upside down U, and a C. So let's go ahead and see. I'm trying to find my other piece of paper here. Here it is. What that notation means. The intersection. The intersection of 2 sets, A and B, now in our case it's different letters, is the set that contains the elements in both A and B. It is denoted by what we have here, this upside down U. So it contains the elements that are in both of those sets. The intersection itself is a set. So what we're going to do is we're going to look at B and C, and we're going to say, what are the common elements? That is what the intersection is. The intersection happens to be common elements. And what is common to both of them? Just the 4. So B intersect C is just 4. And it's also a set, so we have to put braces around it. So there's our answer. You may have done this in an algebra class. This intersection is sometimes known as the AND, because it tells you what is in set B and in set C. Let's go ahead and do another problem. Problem 2, B, and then there's a U and C. Now this U is not to be confused with the universal set, and we're going to see what that definition tells us. Okay, so we have to cover up some of the problem here. The union of two sets A and B is the set that contains the elements in A or B or both. It is denoted by A union B, or A with a U, B. So where the intersection was the and, the union is the or. So it says, well, let's list out all the elements in B, 2 and 4, and let's list out all the elements in C, 3, 4, 5, 6. We talked about earlier, we don't want any repeats in here, so what our final answer is for the union is 2, 3, 4, 5, 6. So there we have it. So the intersection is and, the union is or, and this is the inclusive or because it includes or both, as opposed to the exclusive or, which is either this or that. So it contains all the stuff. To remember these things, maybe, this guy right here is the intersection. If you drew this right there, that looks like a capital A. Okay, so this reminds me that this is the and. And when I taught this class a few times, a student said, this looks like a claw. Remember those claws that come down and grab the toy or whatever? And so this is just going to hand pick what the common element is. Whereas this guy is a U, looks like that. And another student told me that reminds them like of a salad bowl or just a bowl. And you're just pouring all those things in to the salad bowl and you're telling me what the salad has. So we have the and, the or. And now we're going to go ahead and do another new symbol. And this symbol is only used with one set initially, and things will get more complicated. And it's a little mark right there. If you've ever taken calculus, they call that the derivative mark or a prime, so B prime. But what this is something called the complement. So our definition is this: the complement of a set A is the set that contains the elements in U that are not in A. It is denoted by A, and then I'll just call that complement. So basically, this one is what is not in B. So you need the universal set to do a complement. And what is not in B? Well, it would be the numbers 1, 3, 5, and 6. So 1, 3, 5, and 6. So there we have it. And that there, it's called the complement. And what it denotes really is the not. Now when we get to the next chapter and we start studying logic, we're going to see that there's three fundamental operators, and they are and, or, and not. And actually set theory, which we're doing right now, is built on logic. Let's go ahead and do some more examples. So hopefully we've seen that. Good enough there. The next new thing that we're going to get, so we'll call this problem number 4, and the directions are find the following, happens to be, looks like absolute values, but in set theory it has a whole new meaning. So let's take a look at the definition. This is called the cardinality. The cardinality of a set A is the number of elements in A. It is denoted by something that looks like an absolute value. So it's just a number. Notice the other ones, the complement, the union, the intersection, set, set, set. So those ones are sets, but this one's just going to be a number. So it's not that hard to do. How many elements do we see in set B? 2 of them. So the cardinality of B is the number 2. It is not anything with braces. And so those are the 4 new things we're learning. Notice with 1, 2, and 3, the answers from complement, union, and intersection happen to be other sets. But when you just have the cardinality, it is a number. Okay, let's continue. With number 5. Number 5 is A intersect B. Okay, so let's list out what. This is the and, or the claw that comes down and it's going to pick the thing that's common to both sets. So what do we see in both sets? Well, we don't see any common elements. So this is kind of weird. We can't put anything in our set. Our set contains nothing. And our set contains nothing is our last definition here. We'll include this definition sheet within the PDFs. The empty set is the set which contains no elements. It has a symbol. It is denoted by that thing. The empty set is also called the null set. So when we get our final answer on this, this is acceptable, put in the braces with nothing in the braces. But this is what you're going to see a lot more. And so that's the empty set. So something that we do not want to do in this class, so I'll do it in red, is we don't want to say, hey, let's morph them together and get that. This does not mean the empty set anymore. This actually is a set that has one element, and that element is the empty set. I know that sounds confusing. So it's the set that contains the empty set. The empty set is the set that contains nothing. So if you ever took a set theory class, you might do something as crazy as this. So let me put an X through this because we don't want to see this on exams or in the homework. But in a set theory class, you might see the set that contains this. So I'll write it out. And I know what you're thinking. Is this what they do at the university? Yep. And they do other crazy things as well. So in a set theory class, you might get this set right here. So you might want to guess how many elements are in this set. There are 3 elements. I'll underline each of the 3 elements. There's the empty set. That's the first element. The second element is different from the first element. That is the set containing the empty set. And the third element, so there's 3 elements in this set. The cardinality is 3. This third element is the set containing 2 things, the empty set and the set containing the empty set. So if your head is spinning, don't worry about that for this class. I'm going to put it in a cloud. Hopefully you'll never have to see that again. Let's move on to more complicated examples. So let's do the next one here. So number 6. Number 6 says, find the following. A, union, B, intersect, C, complement. There it is. So we're trying to find this, and this right here is going to be a set. In fact, in set theory, you learn how to start out with something very minimal and some basic sets, and you can build a whole bunch of sets using unions, intersections, and complements. In fact, all the math we do is built on set theory. So how am I to do this? Well, the first thing that I'm going to do is I'm going to write this below. I'm going to put these sets in here. So set A is, and I just look up there, it's 1, 3, 5. Union. Set B is 2, 4. And set C is 3, 4, 5, 6. Then there's a complement right there, so we want to make sure we don't miss that. We have that right there. So what am I to do with this? I mean, this does look pretty complicated. It has parentheses, and this looks like an exponent, and then you have these guys here. Well, there is an order of operations with set theory. So remember order of operations in just with arithmetic. And I remember my teacher saying, please excuse my dear Aunt Sally. And other teachers say that's PEMDAS. PEMDAS, okay? And it just means that if you have a complicated arithmetic expression, you do your parentheses first, and then your exponents, and then multiplication, division from left to right, and then addition, subtraction from left to right. Well, this is for arithmetic. For set theory, we have a different one. It looks like this. Parentheses is still the top of the pecking order, and then complements, that's that thing right there, and then unions and intersections. And depending on the context of the class, those might not be on the same level, but in this class I'll put them on the same level, and that's how you do these ones. So this one right here was, please excuse my dear Aunt Sally. I always wondered, what did Aunt Sally do? Well, this one right here, if you want to remember, this is please compliment. This is just one saying. Uncle Ian. Or Uncle Isaac, if you'd like. So that's just a way of trying to help you remember this. The main thing is you have to do your parentheses first. Okay, so we're just looking inside the parentheses and treating that like its own problem. Okay, so we don't really want to deal with that yet. So if I were just doing it inside the parentheses, what is stronger in the pecking order, the intersection or the complement? And the complement is the strong thing. So what I'm going to do is circle that in orange, and that's what I'm going to simplify now. So everything else stays the same. This is 1, 3, 5 union. We have 2, 4 intersect. And then the complement of 3, 4, 5, 6, so we have to look at the universal set and see what's not in there. Well, 1 and 2. And so the orange became that right there. Okay, now the next thing I'm going to do, I'm still working inside the parentheses. I can now take the intersection of those two sets. So what are the common elements of 2, 4 and 1, 2? Well, that would happen to just be 2. So this is 1, 3, 5 union. And we can make the parentheses go away because we don't have any other operations to do in there, so we can just write the set containing 2. Okay, so what just happened? We did this right here, and it became this. Okay, our last step is doing the union. Throw all that into that bowl there, and we'll write them in order. I mean, we could always write them out of order. You want to write your answers in order when you're doing your homework because it will be easier to check your answers. So I'm going to go 1, 2, 3, 5. There's the answer. So when they ask you to find this set, well, we found it. It is that right there. So let's continue and do a few more problems here. Get rid of this. Do this right here. We'll do problem number 7. Problem number 7 says this. So you know what I'm going to do? I'm going to take problem number 6, which is a union B intersection C complement, and I'm going to go A union B, so it starts off the same, and I'm going to group those within the parentheses, and then keep all the signs the same, intersect C complement. So all I've done is I've taken problem number 6 and I moved the parentheses. That shouldn't make a difference, should it? Well, if you've had enough math classes, you know that lots of times it does make a difference. So what I'm going to do is I'm going to write this all out. A being 1, 3, 5. B being 2, 4. And then C is 3, 4, 5, 6. Okay, the highest on the pecking order is parentheses. So I'm going to simplify this first. I'm going to be taking the union of 1, 3, 5 with 2, 4. So that's going to give me 1, 2, 3, 4, 5. And yes, I forgot. See, those things are easy to forget, so I forgot to put the complement there. So we'll write 3, 4, 5, 6, complement. Okay, well, the next thing on the pecking order between intersection and complement is the complement. So that's what I'm going to do now. I'm going to take the complement of 3, 4, 5, 6. And we had done that in the last problem. So this is 1, 2, 3, 4, 5. Take the intersection with, okay, so this is what we're doing. Let me use a different color here. Do this one right here. So the complement of 3, 4, 5, 6 is just 1, 2. And that's what we get right here. And just like on the last problem, I'm not going to do a color for this step because I think there's only one more thing to do. I'm going to take the intersection. So here comes the claw. It's coming down to get the common elements. What are the common elements? The common elements are 1, 2. So when you just move the parentheses around within a problem, it does make a difference, because in problem 6, the answer was 1, 2, 3, 5. So that's how you do these problems. We'll do a few more just to get a little more practice. So let's go ahead and do number 8. And maybe you want to pause the video and see if you can do this problem. So let me write it up first. A union C complement intersect B. So now's a good time to pause and then do the problem. Okay, so what I'm going to do on this one is I can actually become a little more efficient, and that's what I'm going to do. I'm going to try to go for efficiency. The first thing you would do in the order of operations is the parentheses being A union C. So what I'm going to do is I'm just going to look at A and C and just take their union as I write down this first step. So 1, 3, 5 union with 3, 4, 5, 6. So 1, 3, 4, 5, 6. So the purple became that right there. And then there's a complement, so I'll put that right there. intersect B, which is 2, 4. Okay, the next thing on the pecking order happens to be the complement. It's stronger than the intersection, so that's what I'm going to do right now. So the complement of 1, 3, 4, 5, 6 are the numbers that are missing. And we look up here to see what's missing. What seems to be missing is 2. I'm going to go ahead and circle that in orange. So 2, and we're going to take the intersection of 2 and 2, 4. The intersection being the and, or the common elements. And so what are the common elements in both of those sets? Well, there's only one common element. It is 2. So in the next section, we're going to be doing some coloring. We're going to be coloring pretty pictures. This is going to be an important skill to get to the coloring. So we'll have to do this in the more complicated problems, and it will tell us what to color. Let's go ahead and we will do one more like this. So we're supposed to find the set, and then we'll switch over to some other kinds of problems in this section. So problem number 9. C, we do the intersection. We have A intersection B, and this is complement. Okay, so pause the video and see if you can do this problem. Okay, so the first thing I'm going to do, the order of operations, I'm going to do the A intersect B. So I'm doing and. What do you see in A and in B? Well, they don't have anything in common. So what I'm going to do is I'm going to replace that. I could use the empty set sign. I'm just going to go like this instead. I'm going to say there's nothing in there. That's what that became. You can use the empty set sign. And then what am I going to be doing with that? I have the complement there. So that's my first step. So now, what is the complement of the empty set? What do we not see in the empty set that we see in here? Well, the empty set has nothing, and it's kind of like the opposite. I don't know if it's the opposite, but it's not empty, which means full. So, and I know I didn't replace C with what it was, so that's what I'm going to do. So this is 3, 4, 5, 6. Order of operations, it says to do the complement before we do the intersection. So the complement of the empty set is the universal set. 1, 2, 3, 4, 5, 6. I mean, even though it doesn't say it in this problem, the complement of the universal set is the empty set. So this gets colored in green. Okay, so now I just have to do, I'll put some equal signs, the intersection of those two sets. What is the intersection of 3, 4, 5, 6 with 1, 2, 3, 4, 5, 6? Intersection is then the and, the common elements, and the answer is 3, 4, 5, 6. And so that's an acceptable answer. Now when you're doing your homework, and this happens sometimes, where you'll get an answer and then you'll look on the next page at the answers and you'll see something different. So in this case it might be the situation where you look and the answer, it just has a capital C. So what's that all about? Well, that's another acceptable answer because that is set C. Set C is 3, 4, 5, 6. So both are acceptable. Just pick one and use it, and that's what you'll see when you do your homework. Let's continue doing some more set theory, and we're going to switch the problems around a little. So remember in our other example, U was 1 through 6 and A was 1 through 5. Well, they're not telling you what the universal set is and what A is. So we can't just use that scheme that we had in the last 9 problems. So they want us, we say A is a subset of U. Sometimes the visual people might like this, but other people might not like this. What you have, you can do the Venn diagram, and here's U, and here is set A. Oh, by the way, we could have been drawing a Venn diagram for these guys as well. Well, we're not asked that in the homework, but we can do a Venn diagram and put circles A's, B's, and C's in there and put some numbers in there. But we won't do that. But right here, okay, so this is for people who want to try to figure this out. Our very first problem will be A intersect the universal set. So if you're thinking like, whoa, how do we do this? Some of you may be able to just tell me what the answer is. The intersection is really the and. What do you see in A and in the universal set? And some of you are looking at this and you're like, I see nothing. I just see a circle and a rectangle. What are you trying to get at? Okay. For those of you who see this as really obvious, you can move on and see if you can do the next one that I put up. But for those of you who are like, this is really abstract, when you get a problem like this in your homework, maybe let U be 1, 2, and let A be just one of those. So we'll just let A equal 1. In terms of the Venn diagram, you can have 1 there and 1, 2 there. So in blue, what I'm going to do is I'm going to write down what A is. A is just 1. And the universal set is 1, 2. Now this gets something that we can actually touch. Let's take the intersection of 1 and 1, 2. This is the claw, this is the common elements, and the answer then is 1. But that's not the answer to this question because we just made this up, 1, 2, and 1. And so we want to look out here and say, well, what is 1? It happens to be letter A. This kind of reminds me of the end of problem number 9 where we put letter C there. So this right here is the answer, A. And some of you got it right from the beginning because you're saying if you color everything that's in A like one color and then color everything that's in the universal set another color, so that's everything that's in that box. The intersection means where do you see two colors? What part has both colors? And that would just be circle A. So some of you were able or are able to analyze these things without going to the blues. Let's do another one, okay? So this is problem number 2. I have A union the universal set. So once again, there's some people in here that are like, oh, you pick out everything that's in A or the universal set or both, and you're able to just put the answer. But if you're not one of those people, do the same thing where A equals 1, 2, U equals 1, 2, and A equals 1. So I'm going to write out below like I did on the other problem, except there's a union here. And then what is the union of 1 with 1, 2? It would be 1, 2. Now that's not A, but what is 1, 2? 1, 2 is U. And that's the answer there. Okay, let's do a few more of these. I guess I'll put 3 right here. A intersect the empty set. Okay, so what are the common elements between A and the empty set? And once again, some of you might say, oh, I know what it is. We'll see if you can get this one by pausing the video maybe. Okay, A has this element 1 when I did this blue labeling here. The empty set Well, what element should I put in there? Well, nothing. So now we're asked, what are the common elements between 1 and the empty set? There are no common elements. So that doesn't look like universal set, that doesn't look like A. This actually looks like the empty set. So there it is. And some of you could have figured this out. They're like, what are the common elements between set A and the set that has no elements at all? And you figured out, oh, well, that has to be the empty set. Now, if you didn't figure it out that way and you had to do the blue way, there's nothing wrong with you. Why don't we go ahead and do our last problem of this section, and this should help you do your homework. We have A union the empty set. Okay, so A is 1 with my relabeling here, and the empty set is, we don't want to put 0 in there, it's just, there's just nothing in there. So what is the union? You're putting this all in a salad bowl. You empty that into the salad bowl and empty that, which nothing came out. So what's in the salad bowl? What do you see in the first set or the second set or both of them? Just 1. And so our final answer for this problem is A. So when you're doing these problems, you don't want to write your answer as like the set containing 1, because we just came up with this 1 too. So that is pretty much the rest of this section 2.2. In this class we are going to skip 2.3. We just don't have time to do it. It's interesting, but a lot of you will be happy that we skipped it. And our next video will be 2.4. And let's get to the puzzle here. What letter comes next in the sequence? Some of you may have figured it out, and let me help you out if you're still trying to figure this out. Look at the first letter of each word in this question. And so I know some of you hate me for doing this. So what letter comes next in this sequence? Starts with an S. You guys have a good day.